basically, we talked about inverses yesterday, specifically what makes an inverse, how we know if a function is an inverse of another function, things like that. But we didn't actually get into the nitty gritty of how you find an inverse function from another function. All right, we kind of didn't do that step just yet. So what we're going to do first is this journal entry. It's one of 3 for inverses, but this is the only one we're doing in class together. All right. This is 1.3a. So as always, you always have your I can statement at the top. So at the top of your journal, you're going to write this. So 1.3a, it's I can find the inverse of a function using tables, graphs, and equations for linear and quadratic functions. All right. So essentially what we're going to do, we're going to start with reviewing what we learned yesterday, which is going to be the definition, the table, and the graph section. And then the new part is going to be essentially what we briefly discussed with your exit ticket from yesterday. So how to go from your starting equation to the inverse equation. All right. Now, let's start first with the definition. So first off, just as review before I even write anything down. When I say inverse, what was the one thing that I told you that should come to mind whenever you hear the word inverse function? Opposites for one. What about x and y? Switch x and y, okay? So inverses, they're opposites, they undo each other, and you always switch x and y, all right? Those are the 2 main concepts, all right? So if we put that into words, an inverse is defined by reversing the inputs, which remember that's just another word for x, and the outputs, which is another word for y, of a function. All right. Specifically, that's like a lot of words, but specifically, all you need to remember when it comes to the definition of an inverse is that you switch x and y. That's like the bread and butter of anything inverse. That's like your first step for when you're solving the equation. That's essentially what you do if you're going from a table or a graph. You just switch the x and y. And then you also just need to know that they undo each other. So, like, for example, that was when yesterday we did all those compositions where, if you guys remember, where we put a number into one function, got the output, then put that number into the other function, then we ended up with the exact same thing that we started with. You guys remember that from yesterday? That's what they mean, undo each other. All right, so one function, like I said yesterday, if one function ties 2 knots, the other one should undo those 2 knots. All right. Also, guys, I know my handwriting leaves much to be desired. So if you ever like, I have no clue what the heck that word says, whatever that chicken scratch you just wrote, just ask me. You're not going to hurt my feelings. All right. It's worse with the tablets. So. All right, now we're going to start by reviewing what we talked about yesterday. So tables and graphs. That's what we mainly focused on yesterday, going from tables to graphs, or going from finding inverses from tables and finding inverses from graphs. So we're going to start with the easier of the two, which I believe is the table. So with a table, it just means that each ordered pair is reversed. Meaning, if you start with xy, your inverse will be yx. All right, so in other words, this would be your original. This one would be your inverse. Now, let's actually write out an example of this. So, I'm going to give you the original function table. So, let's say you were given a function with this table. So, xy, and you have 2, 3, 4, 7, 6, -5. So, that's what you're given to describe the function, is that table. Now it's asking for us to find the inverse table. All right, so that means we're going to have x and then y to the -1. Remember, if it's raised to the -1 power, that's just the notation saying that it's the inverse of y. That's all that -1 means, just means inverse of y. All right. So someone raise their hand and tell me, if I go from 2, 3, what's the inverse of that? It'll be 3, 2, right? Someone else tell me, if we start at 4, 7, what's the new point? 7, 4. And then 6, -5, what's the new point? -5, 6. Good. It's literally as easy as flip-flopping the rows. You just literally flip-flop those two values. All right. Now, that's with a table. A graph is very, very similar. All right. It's still just switching x and y. So I'm going to draw a graph here. All right. So I'm going to draw f of x. So I'm going to have a point here, here, and here. So this is my f of x. It's a quadratic graph. And just to note, the points listed here are -1, 2, 0, 1, and 1, 2. Now, if those are the points connected to f of x, that means the points of my inverse graph will be what? Someone raise your hand and tell me 1 point. Layla. Say it one more time. 1, 2 is one of them. What's another one? Oh, wait, not 1, 2. 2, 1. Yeah. I knew what you meant. 2, -1. Good. And then what's the last one? 1, 0. All right, so I'm going to graph it really quickly. So 1, 0, 2, 1, 2, -1. And so this will be f -1 of x. Remember, that's another way to denote that it's the inverse. Now, a couple of key features about this graph is that f of x and the inverse of f of x are reflections across the line y equals x. So this is review from math 2 because I literally just taught my math 2 kids this the other day. But if you draw the line y equals x, which is just a diagonal line with a positive slope of 1, and it goes through the origin. All right? Literally the generic linear graph. All right? The rule for reflecting across y equals f of x is literally if you start with xy, the reflection will be yx. So it's literally the same rule as it is for inverses. It just means switch x and y. All right. But hint, hint, wink, wink, you may be asked on your test, what line is your inverse reflected over? Hint, hint, wink, wink. If you know y equals x, you're golden. Okay. Now, another thing to note is that they can intersect often on the line y equals x. So, for example, if you had the point 4, 4, if you flipped x and y, what's a new point? 4, 4. All right. Because they're the same number for both parts of the point, it still gives you the same point. All right, sleepy babies, heads up. So, graphing inverses should be one of the easiest things you do because all you got to do is take a couple points from the original, flip the x and y. Those are your new points. All right. Same thing with the table. You just flip the x and y. That's all I got to do. Now, we're getting into the new part. So, any questions on the stuff as we essentially talked about yesterday? All right. So, any questions so far? All right. So, now let's talk about equations. So, again, we briefly discussed this with your exit ticket yesterday. All right. Again, I gave you that exit ticket because I wanted to see if you could figure it out or at least somewhat get it after I got you started on it. But with the equation, all right, here are the steps first on what to do. So you would first rewrite the equation switching the x and y. And what I mean by that is I literally mean if you have y equals 2x, when you switch x and y, is now x equals 2y. All right, I literally mean flip-flop the position of the variables. Now, once you do that, you get into solving land. So you solve for y. And then your last step is to write your final answer using y to the negative 1 or f negative 1 of x. All right, just so it's denoted that that's the inverse. So this is about the precision, all right? So one of the things in mathematics that's very important is your precision, and that comes from writing correct notation. Now, we're going to do a couple of examples on this. So we're going to start with a very easy one, and then I want to do like 3 more examples after this that you're going to write on the others. Well, I'll explain it in a second. Okay, so we're going to do this first example. All right. So, example 1. So, we're going to start with y equals 2x minus 4. So, we're going to start very simple. This is going to be a linear function, and our inverse should be linear as well. All right. Now, our first step, like I said, is to simply switch x and y. And I literally mean flip-flop where those two variables are. So we now have x equals 2y minus 4. Now, we are then going to solve for y. All right. Now, that says it's like, oh, it's just one step. You solve for y. That could take 2 to 3 steps at least, the actual solving process. So, how I explained this earlier today is think order of operations. All right. So, PEMDAS. When you're solving an equation, because a lot of times what I see kids do is they don't know where to start. Well, when you're solving an equation, you're undoing PEMDAS. So in other words, you're doing SADMEM. All right. So you're going backwards with PEMDAS. So SADMEM. That's what I'm calling it. All right. So if we go backwards with PEMDAS, what do we typically start with? So what's the last thing you typically do with PEMDAS? Subtraction, addition, right? So I need to take care of anything subtracting, adding first. So am I adding or subtracting anything to y? The negative 4, all right? Another way to think about this, guys, is if the two variable thing is throwing you off, we're treating x like a number. So sometimes you can say, okay, just for example's sake, I'm going to say x is equal to 5. It's not true. I pulled it out of my butt, but you know what? We're going to roll with it. So I'm going to rewrite this with 5 equals 2y minus 4. Well, now it's a little easier, right? So we would add the 4 to both sides. All right. I'm going to rewrite this as 5 plus 4. I'm not going to evaluate it's 9. We all know it's 9. I'm just not going to write it into existence. You'll see why in a second. Then what would I do? Divide by 2. That goes away. So now I'm going to leave it like this. We know my answer is going to be 9/2. I don't care that it's 9/2. I just want to know where I have to put the x again. So I'm going to erase one of these numbers and replace it with x. Which one? 5. Let's say x equals 5. Boom. Answer done. Y is equal to x plus 4 all over 2. All right. So if the two variable thing confuses you, plug a number in. All right. But don't actually evaluate it. Meaning, like, don't actually do the addition. Yes.
Wouldn't they make that x plus 4 over 2 or simpler? That's good.
You could. You could. I'll explain that in just a second. All right. Honestly, if you can get to right here, I'm happy. Because you can simplify, but I'll do that in a second. So, if I did it the old-fashioned way, I would first start by adding the 4 to both sides. Meaning I would do x plus 4 is equal to 2y. Still solving for y, so I got to divide by 2 to get y by itself. I get x plus 4 over 2 is equal to y. So the solving bit was our second step. And then our third and final step is rewriting using the -1 notation. So y of -1 is equal to x plus 4 over 2. Now, like Mackenzie said, we could technically simplify it, so we can technically break apart that fraction into x over 2 plus 4 over 2. All right. So another way you could have written your answer is f -1 of x is equal to 1/2 x plus 2, because 4 over 2 is 2. Now, in my opinion, guys, if you can get here, I'm happy. If you don't trust yourself to simplify that correctly, don't. Okay? As long as you can get it so that y is by itself on one side and it may look like a mess on the other side, I don't care. All right? If it's something that you can still like maybe plug into Desmos if you need it, great. Okay? That's what I need. So don't worry about simplifying. I'm happy if you can just recognize how to do the actual math, like how to get it down to where y is equal to something. Okay? If you can simplify it too, kudos to you. If you want to simplify, go for it. But don't kill yourself to do it. Okay, so don't kill yourself to simplify. If you got it to like y equals something, you're done. Okay? All right, come on, guys, heads up. So we're going to do 3 more examples, and they're fairly quick, and then I'll give you guys a 5-minute break. But you guys suffer through that. Yes? Say one more. The break. Okay. All right. So what I want you to do now is on the left side of your notebook, so that space is on the left side of your notebook, we're going to write in some examples. So these are types of examples that you're going to see on your Delta Math for 1.3. So I want to do some like it so that you could see them. All right. So we're going to start with example 2 where f of x is equal to 2x squared plus 5. Now, when we're doing examples like this is where SADMAP comes in handy. It's PEMDAS backwards. Because this will tell us what we need to do to get our variable by itself. All right, what order we need to do things in. It's a good way to think about when you're solving any equation. All right, at least any linear equation. All right, so first off, if it ever has f of x, I just go ahead and rewrite it with y in place of f of x because it's the exact same thing. So y is equal to 2x squared plus 5. That's not an official step. It's just the thing that I do because, I don't want to deal with f of x. I want to deal with y. All right? They're the same thing. They're synonyms in math. They mean the same thing. F of x is the same thing as y. Now, what's our first step when we're dealing with inverse? For anything inverse, what's always the first step? So we're not in solving land yet. I just want the first step. Switch the x and the y. So I now have x is equal to 2y squared plus 5. Now we're in solving land. All right? So this is where SADMET comes in. We're doing the opposite of PEMDAS. We're going backwards. Say one more time. Right. So, first part of SADMET is the sum. All right? So subtraction, addition, we got to get rid of one of those two using the opposites. All right? That being, we're adding 5 to our y squared of some sort. So we need to get rid of it by subtracting 5 to both sides. So I'm going to subtract the 5 to both sides. What am I left with on the left side of the equal sign? Left side. Closest to me. X minus 5, good, is equal to 2y squared. Now, here is where SADMET really comes in handy. Because I can tell you right now, I've seen this 1,000 times, the most common mistake that I see students do is when they get here, they want to take a square root right now. Why can I not do that? So why can I not take the square root yet? Because why? We have to divide first. In other words, the y is not by itself yet. We got to get rid of that 2 first before we can even touch the square. So a square is another name for a what? What part of SADMEP is a square? It's an exponent. What's this 2 a part of? What operation is this 2 doing to the y? Multiplication. What comes first in SADMEP? Multiplications. What do we have to take care of first? The multiplications. We got to get rid of that 2. How do I get rid of it? Divide both sides by 2. And I mean divide all of that side by 2. So that goes away. I'm left with x minus 5 all over 2 is equal to y squared. Now we are at the part where we can deal with the exponent. And remember, whatever the exponent is, you undo it with that same type of root. So for example, a square root undoes a square, cube root undoes a cube, fourth root undoes a fourth. All right? So I'm going to take the square root of both sides. And everything on the left side is going to be under that square root symbol. Now, because we're taking the square root of a square, that cancels out. It's gone. We're just left with the y. So I'm left with square root of x minus 5 over 2 is equal to y. And I'm going to tell you right now, don't even try to simplify that. Leave it. Okay? Just leave it. I'm happy. Miss Murphy happy with this. Okay? She's a happy camper. She's happy with that. Okay? So, then our last step. So I forgot to label it, but we started solving right here. Our last step would be rewriting it with the inverse notation. So I'm going to use the f of x because that's what we start with originally. So f of negative 1 of x is equal to square root of x minus 5 all over 2. Now, if you forget to rewrite it at the end, as long as I see this, I'm not going to take off like a bunch of points for it, but just note that when it comes to precision, the notation does matter. I'm not going to be a stickler about it, but you never know. You may end up with another teacher that's a stickler about it, or the EOC or even your Delta Math can be sticklers about it. Okay? So just be careful with that. All right, any questions on that example? So that was an example of a quadratic. Let's look at another quadratic example that's a little bit different. Still quadratic, but the order of steps is not quite the same. So we're starting with y equals 2 times x minus 5 all squared plus 1. So first things first, we're just going to rewrite it using switching the x and the y. So I have x is equal to 2 times x minus 5. Why did I write x again? 2 times y minus 5 all squared plus 1. Now, again, SADMEP is your friend with this, okay? Because, especially when we get to say about here, it'll clear up some things for you, okay? Wait. So, if we're looking at SADMEP, what's the first thing we got to deal with when we're in solving land? Addition, subtraction. Now, I have 2 different operations that can qualify as addition, subtraction. Which one do I need to touch right now? The 1. Why do I not want to touch the 5 right now? It's in parentheses. And where does parentheses fall? At the very bottom. So we want the addition subtraction that's not within the parentheses. So I'm going to subtract that 1 first, just like Jackson said. So I'm going to subtract the 1 to both sides. That goes away. I'm left with x minus 1 is equal to 2 times y minus 5 all squared. All right. So we did the sum. What comes next? What's the next thing we got to tackle? Multiplication, division. Do I have any multiplication or division in here? Sure.
The 2.
The 2. Remember, if there's no operation between a number and parentheses, we have to assume it's multiplication. All right? Now, your gut feeling is probably to distribute. Don't do it. Okay? You can't distribute because of that little 2 right there. All right? However, we can get rid of that 2 very easily. How?
Divided.
Divide it. All you got to do is divide it out. So don't make it harder on yourself by distributing, because first off, they'll be wrong. Second off, like, why bother with that? Okay, you'll end up just having to divide 2 later on. So we're just going to go ahead and get it over with and divide the 2. So this is now x minus 1 over 2 is equal to y minus 5 squared. Now, right here is where a lot of people get tripped up, because I've seen a lot of students in the past try and move this 5. However, based off the SATMEP, what do we have to knock out first? The exponent. So I need to get rid of that square first before I can touch the minus 5. Because the minus 5 is in where? Parentheses. It's in parentheses. We can't touch it. Okay? So how do I do a square? Square root. So I'm going to take the square root of both sides. Now, that may look complicated on the right side, but in reality, boom, it's gone. We're left with whatever's under the radical, which is y minus 5. So I'm left with the square root of x minus 1 over 2 is equal to y minus 5. So the parentheses are technically gone now because that's all that's left. So what's my last step here? Add the 5. So if we add that 5 to both sides. Now, let me ask you a question. Am I going to add 5 under the radical? Or is that add 5 going to go outside the radical? Outside. Why can I not put it under the radical with everything else? Like, why can I not? Right. So the radical already exists. All right. We can't like just add the 5 to this negative 1 and call it positive 4. We can't do that. Because since the 5 is not already within the initial square root, we can't just kind of force its way in. All right. It's got to have an invitation. It doesn't have an invitation to the party. It got to stay outside. Okay. So this will be square root of x minus 1 over 2 plus 5 on the outside is equal to y. So if we rewrite it using the correct notation, our inverse of f of x is equal to the square root of x minus 1 over 2 with plus 5 on the outside. All right. So all my sleepy babies, heads up. We got one more, and then we're done. And this one's quick. All right. And then I'll give you your 5-minute break, and then I'll tell you what we're doing afterwards. Okay. It's the last one after this one. All right. Any questions on that one? All right. Last example, and then we'll go on break. So this is one that's similar to the exit ticket. All right. So now instead of undoing an exponent, we're undoing a root. We're still going to treat it like it's an exponent. All right. So we're doing y equals 3 times the 4th root of 2x minus 5. Now, I'm going to tell you right now, whenever you deal with anything radical, whatever's under the radical, treat it like it's in parentheses. All right, because that'll help you when you do your SATMEP. All right. So, first things first, switch that x and y. So I got x equals 3 times the 4th root of 2x minus 5. So now I'm in solving land. So based off of SADMEP, what do I need to move first? The -5. How do I move it? By adding. So I add 5 to both sides. This goes away. I get x plus 5 is equal to 3 fourth root of 2x. Now, based off the SADMEP, we knocked out subtraction addition. What's next? What comes after the sub?
Divide by 3.
Right, you would divide by 3. So, remember, even if it's a radical, we treat it as parentheses almost. So, if there's a number and there's no operation between that and a radical, that in parentheses, that in absolute value symbol, whatever, we assume it's multiplication. Okay? So, we have to divide by that 3. So, we're going to divide both sides by the baby 3. So this becomes x plus 5 all over 3 is equal to the fourth root of 2x. Now, like I said, the next step, we're treating the root like an exponent, because technically you can rewrite a root as an exponent. Technically it is an exponent. Now, think about this carefully. If I have a fourth root, what undoes a fourth root? Think about the x ticket from today, or from yesterday. So what undid a seventh root? If you raise it to the what power? 7. So what do you think undoes fourth root? If you raise it to the fourth power. So guys, whenever it comes to roots, whatever that little number is in the corner, that's the power that you're going to raise it to undo it. Okay? So the seventh root, raise it to the seventh power. Fourth root to the fourth power, square root, square it. 10th root, raise to the 10th power. All right? It basically tells you what to raise it to. So we're going to raise both sides to the fourth power. So the root and the fourth cancel out on the right. I'm left with x plus 5 over 3, all raised to the fourth power, and it's equal to 2x. Why did I put 2x? It's 2y. Guys, I put like x here like 50 times. Why did you not catch me? Oh, please correct my mistakes. Miss Murphy gets into the groove of things, and then she doesn't realize until later that she's dumb. Okay? Please correct me. All right. So, what's my last step here? Dividing by 2. And we're going to divide this whole thing by 2. And again, don't even attempt to simplify it. That blue bad boy monster up here, just leave it. All right? You can get to here and I can follow your process. I'm happy. That's all I need. We're done. Checked it off. You're good. All right? So, you would get x plus 5, oops, not big enough, over 3, all raised to the fourth power, divided by 2 is equal to y. So if we do our last step with writing it with the correct notation, f negative 1 of x will be equal to all of that. So does that make you guys a bit more comfortable with finding the inverse functions from the original? All right, so again, and this goes for pretty much any equation you guys solve for. Just think SADMEP. All right, if you don't know where to start, think SADMEP. It'll tell you where to start. Okay. All right, so here's what's gonna happen. And don't move yet. I'm gonna give you your 5-minute break. When we come back, I need you guys to take out your Chromebook and get into Wayground, which is the new quizzes. All right. A lot of you have not signed up for that. because I checked this morning, there was only like 5 of you out of 21 that signed up for it. So you need to go back in, sign up for it if you've not done it already when you get back from your break, and then I'll tell you what we're doing from there. All right, so I'm gonna set my timer. Again, make sure you're back before that timer goes off.